Hi everyone, welcome back. This is Raju from Smart AI Technologies. Today we're going to see a demo of the project called Real-Time ATM Monitoring System using deep learning by detecting helmet, mask, weapon, and also more number of people than limited. So based on these four parameters, it will pop up an alert saying if there are multiple people, it will say more than two people are there or more than one people, like whatever the restricted is, and go out of ATM. If helmet is detected, please remove helmet and use the ATM. Here you can see the result on the screen. Okay, so mask detection is safe, weapon is detected or like that. So the detections will be happening and in real time voice alert will be popped up. So this is our project and we'll see more about this project, but before that we'll first check a few IEEE papers and
People
what they
are
are.
more than one. Please remaining people go out of ATM. Please remove helmet and use ATM.
Okay, so it pop up an alert. So just like that, it will pop up alert for different conditions. We'll check in depth how this project is working. But before that, we'll check few IEEE papers. So if you are new to our channel, we Smart AI Technologies provide complete project support like IEEE based projects mainly. So already we have posted so many videos, you can check there, and we have implemented so many good projects, and this will be one of the very unique project, and where you can use it for research, and it will be worth. We will check with few research papers and base papers or references that whatever we are using. The first paper is this one, Deep Learn Helmet Enhancing Security at ATMs. So what does this paper contains actually, and what they are implementing, and what is their proposed methodology, and what is the existing system. Their proposed methodology will itself will be existing system for us. Okay, we need to think about this. So once when we go through this paper, we find three things. They are using AlexaNet, VGGNet with RCNN. So these three deep learning models they are using. And when it comes to database, they are collecting few images only for helmet. They are doing. You should keep this in your mind. Only they are doing helmet detection. Only one part they are doing. For this, they are creating their own datasets around 950 images. If I am right, the 950 images they are collecting from the Chrome or from Google, and they are making it as a folder, and they are building a database. Now these are the samples of the database that they are using, and in their proposed methodology they are very clear what are the models they are using. They are using AlexNet and CNN, and no, AlexNet, RCNN plus VGG. AlexNet, they are giving details about that. And accuracy around 96%. That means if they are providing around 100 images as an input, they are getting around 96 images predicted right in their cases. So they are making it as a tabular data, experimental. Under their experimental results, we are getting those things as they mentioned, and you can see the graphs also. Finally, they are showing a demo of a single image. They implemented it on an image, so they are presenting it. Now, what they are doing to detect the face in the given image is RCNN. Okay, after detecting it for the classification, they are using AlexNet or VGGNet, or sometimes they are even trying or testing for CNN, that is custom CNN model. These are all transfer learning. AlexNet and VGG, all these are transfer learning models, whereas RCNN is actually detection model. So by the combination of these models, they are detecting only helmet presence, whether there is a helmet or there is no helmet. Now this paper doesn't speak about any other parameters, like what will happen if multiple people are there in the helmet, what will happen if there are people who are wearing mask, and if a person is wearing having a weapon with him. So there are so many situations for that. This model is not speaking anything about those things. They are concentrating only on helmet. So the existing system for us from this paper is actually only helmet detection. They are doing existing system is helmet detection with RCNN plus AlexNet. Now we'll check with second paper, where this paper speaks about weapon, helmet and multiple people. It means here in their proposed system, in this paper, they are trying to predict if someone is having a weapon, or if someone is wearing a helmet, or if there are any multiple people. Now when we go through their proposed methodology, proposed system, we in this paragraph we see few things very clearly. What they are doing for these detections, it means the methods will be more important than the title. If I say weapon detection can be done in multiple ways, or using multiple techniques, multiple models. So which one they are using, and whether that is more sufficient, or is that having any problem? So that will be existing system, and it's a loophole. So we need to check like this. So now when we go through this paper, they are mentioning very clearly that R cascade and local binary pattern histogram methods, these methods are not that much accurate. These are all, these two methods are like, they have so much of problems. I will discuss about that. Okay, first thing is they are using R cascade for multiple people detection. So normally this R cascade is actually a freely available model or library like stuff. Okay, it is from CV2 itself. Using that you can detect eyes, face, person, like that. Okay, there are some predefined functions. So using it, they are detecting the person, multiple people or number of people they are counting. But the problem with R cascade is it's not that much accurate, and it is having a restriction. For example, if you use R cascade to detect a face, if he is faced towards you, you can detect using the R cascade. If he is facing back, you can't detect. If he is facing his face is cross, you can't decide, because in R cascade you have frontal face, frontal face are like that. So when the face is side viewed, it will not give good accuracy, that frontal face of R cascade. So there will fail like that. So these models having a much drawback. They are old, and the way that is being used to detect using R cascades are much old, because they are done with help of points. Okay, there are some predefined points. If it need to detect a face, it need to detect that predefined points on the face, then only it will say it is a face. If face is tilted little bit, the points are like if there is something on the face, it will fail. R cascades will fail. Okay, so that's why even though they are doing multiple people detection are like that, it will not be that much accurate. And even same happens for LBPH. Okay, based on histogram. So histogram nothing but the intensity, pixel intensity based are like that they will do, but again it will also be that much accurate. So accuracy is the key. They are using old methods to do this project. So this is the biggest loophole, and we have a problem here. So we should solve this problem of this paper. So that will be our proposed model. And now you can go through these papers, and once you contact us, we can give you these papers. Okay, you can refer them, and once you contact us, you can take the whole projects and the codes, and also we'll be helping you with the mentorship. Okay, if once you take the course and everything, if there is any problem in the course or like that, we will be helping you, and we'll be setting classes to make you understand these things. We'll be giving a complete service about these projects. Now we will go and check with the third paper. So this paper is actually very basic level one. So this paper says a smart unusual event detection. When we go through this paper, they are again using our cascade, which fails to detect that you are seeing here in the image itself. So it should detect only face, box should be around only face, but why it's coming around outside of the face? One box. Here you can see eyes. There are three boxes, only two eyes are there. Three boxes are coming. So like this, our cascades will fail in so many situations. That's why I'm telling you this paper is also doing only face detection. What they are doing is they are using our cascade to detect only frontal face, and then if there is any element over the face, it may not be mask, it may be something. They are mentioning it manually. There is no special alert system. So this paper is very basic, third paper. So when we combine all of these, finally, what is the existing system that is there from this paper is at present paper one. According to paper one, they are using RCN and AlexNet to detect only helmet. It means only helmet detection with RCN and AlexNet is there. And the second one is they are using R Cascade and LBPH, even though they are doing weapon, helmet, multiple people, but they are using old technologies or old techniques which are not accurate. And the third paper is very basic, which is using R Cascade to detect human face, and if there is something over the face not like a mask, it can't detect properly. So even it is not having any alert system. All these papers are not speaking about much about alert system and how they are doing, in which combination they are doing in depth. Now what will be our proposed system? In our proposed system, we are using four features. One is element detection, mask detection, weapon detection, and counting multiple number of people if they are in the ATM. So we are using first of all four features which are not there in these three papers together. So that's one of our extraordinary work. And when it comes to technologies, what we are doing and how they are overtaking this. So when it comes to paper 1, we are using VGG5, VGG3 in combination. You can use VGG8 and VGG11. Why we are going to VGG5 and VGG3 is they are fast, okay, and accurate also. So when you increase the VGG levels, VGG11, they may be the having a better accuracy stuff, but the problem is they are little bit slow. So while we implement, for that purpose we are going to VGG7. VGGs are actually detection models which are specially trained for the detection of that particular part. So these will be having better accuracy compared to our cascade. So we are overtaking the second paper. So LBPH and R cascade, our models are trained. Okay, we trained the model. We got a data set, we labeled them, and we trained the model. So our work will be far better than LBPH and R cascade of the second paper. Even the second paper is having so many features, but the accuracy will be low compared to our models. So we are using for weapon detection, helmet detection, and also for mask detection we will use VGG5. Whereas for multiple people, we are using VGG3 in combination. You can even go for VGG5 with that, and we can do multiple combinations there. So we are training separate models together so that we can get better accuracies. And when it comes to accuracies, we are getting lot better accuracy, around 99, 95, like that for particular image. Okay, if you take the average of it, it depends. Okay, around 90, 95, like that it will come. So that was our proposed system. And when it comes to databases, first paper is using their own database. They collected 950 images. Second one is using again already available database, and also they are using custom dataset too. And the third one is again they are using custom dataset. In our case, we are using again a used dataset of helmet, mask, and weapon. Okay, we label them with the help of label img. Label img is a tool using which we should prepare a dataset for our YOLO models. Okay, we need to few data we collected from the sources, and few we label them with the tool. So we made a complete dataset first. Okay, separate dataset for weapon, helmet, and mask, and multiple people. So this is our proposed system. So this is a web application which we built using HTML, CSS, and little bit JavaScript in the front end. And for the back end, we are using Flask. So by integrating HTML and the Flask, we built this application where now we had added three pages. For the first page, this is the home page where you can navigate to the next page where you can start this monitoring stuff. So either you can click on the monitor page here, or either you can click on here, protect ATM fraud using our service. So when you click on it, it will take you to the next page. So here this is the main button or the starting button. Okay, when you click on start button here, the camera will start and the surveillance will start to happen. So once you click on the start button here, automatically camera will open and the monitoring will start. Now I kept my camera to this image. You can keep it to your face or anyone wearing helmet or mask. Okay, I am testing it on this image. So I have a separate webcam, so which is USB based webcam. Now it will open that camera here itself. Now it's started to record this in real time, and it here I coded specially to take first 10 frames continuously. Once it takes 10 frames, then it can alert better. For example, if I start to alert for each frame, so now there what will happen is every time the alert should come again and again because the frames will be so much faster. So now I am taking 10 frames together and I am taking average within them. So if 10 frames, how many people were there in that? 10 frames will be very fast, okay? That you should keep in mind. So now two people, three people, four people, how many people are there in the screen? So that will be result here. And helmet detected, it says helmet is detected. Yes, of course all of them are wearing helmet. Mask is detected, they are wearing something to the mouth, okay, just like a mask. Okay, so it says mask is detected. And weapon is detected, and sometimes it says safe. For that only I'm taking average. One or two frames in 10 frames will go wrong, so I'm taking average of it. So average will be anyway mask or helmet detector. Once these things are done, once 10 frames are happened, so it will pop up a voice message, voice alert. So if more than one person are there, please remaining people go out of the ATM. Okay. If helmet is detected, it says okay, please remove helmet and use. If mask wear persons are entering, it will say please remove the mask. And if someone is entering with the weapon, it will say please take away the
People are
weapon.
more than one. Please remaining people go out of ATM. Please remove helmet and use ATM. You're having weapon please you are not allowed in ATM.
So that mask is now not detected because the mask like structure is there. Few frames got misunderstood, okay, that has a mask, but many frames, okay, average frames they are saying there is no mask. Okay, so that's why it is safe, there is no mask at all. They are having that helmet one belt itself just like a mask. So now the results are more accurate, okay, very highly accurate. So we can test it on some other images. So I can feed some other images here. Let us say this one I will take. I will replace it with this image. Those previous 10 frames are now being processed, and for each feature there is a YOLO model running in its backend. I will show what are the models are there, how much complex the coding is. Okay, so those things I will let you know in depth. So for every feature we are training a model, so our accuracy will be very high compared to any other works. And also we discussed about it, I think, clearly what is the existing system, what is the proposed system. So our proposed system is using combination of YOLOs 5 and YOLO 3, and you can use YOLO 7, 11, or like that. It depends on the requirement. If you come up with your own interested YOLO version, we can take it and we can work on it. But in our case, for the purpose of speed calculation, okay, so we are using this one. Now say helmet is detected, so weapon is detected, only one person, okay. Now person is properly detected and it says mask is detected, but
People are more than one. Please remaining people go out of ATM. Please remove helmet and use ATM. You're having weapon please you are not allowed in ATM.
so this voice result was for the older 10 frames. Okay, now these new 10 frames will be generated. Now it will try to detect what is happening. Okay, and based on that the result will be alerted. Okay, so now helmet is detected and it says mask is detected because they are wearing something over the mouth. Okay, and many frames will make it false. Okay, and weapon detected, weapon is 100% detected and only one person is there. So this how our project is working accurately. And I can take out and I can feed few more images. For the mask we'll feed this image which is very small. We'll try this. So I'm keeping my camera over this image. So my camera is now will record this and will predict on this. So before that it will try to process the previous 10 frames. Once that is done it will come here. So everything is happening in real time. Only the thing it is lagging by time is that each frame is need to pass through multiple models, those multiple models to detect. Okay, so these complex models will take little bit of time even though we are using YOLOv5. If we try to go with more
Please
complex
remove
model.
mask before using ATM. You're having weapon, please you are not allowed in ATM.
So now you see it will collect the present frames and it says mask is detected. So let it get enlarged, that zoomed one image, so it will try to give us the proper result. So anyway mask is getting detected 100% because this situation only the mask is the thing. There is no weapon, there is no helmet and only one person is available. Okay, so this is a very accurate result. You can make it to a real world, it will work like this only, this much accurately it will work. So no weapon, no helmet, only one person but he is wearing mask. So now the alert should be please remove mask and use the ATM. Okay, we'll check that alert. What will be the alert? So then we'll go back and I will show you what are the different codes we done, what are the data set and what type of data set we used and how the results we tested on single images then we implemented here. Okay, so if you approach us we'll be giving complete coding, complete support to make you understand what we did in the back and how we trained the model, how we labeled, if needed labeled models and everything. Okay, everything will be taught to you, classes will be taken and also mentorship will be given accordingly with documentation. Now it will pop up alert, you can hear it.
Please remove mask before using ATM.
Okay, that was the alert which says please remove mask. It is not telling please remove helmet, it is not telling more than one people are there, it can't because it is getting to know only that is the issue. Okay, now we'll discuss more about the a small part of our codes. Okay, this is our main application code folder where we have all the codes, okay, whatever we used for detecting. So app.py is the main code which is written with help of Flask, and in template folder there are all HTML files. In static we have CSS, images and script files. Now this app.py will be used to fetch the details or the commands from the front end, and once it gets the commands it need to feed that image in real time, it need to fetch the video or images frames. That will be done with help of OpenCV. Okay, once it fetches it need to feed, okay, it need to feed to multiple models and then get the prediction done back and it should display there. So all those things will be done. For that I have a monitor main.py, so which helps app.py with detecting all those stuff. So here it will start to capture videos frame by frame, and then here it will try to detect. First helmet will be detected, okay, then mask will be detected, and then it will detect the weapon. So all these things will be getting detected, and those things will be stored. So here we'll be storing that in a list, and for continuously 10 frames. If in the 10 frames in average, so we are taking average of 10 frames. You can do it for each frame, but that is not suggested because it will override one frame over other frame, because the displaying audio itself will take little bit time, or alert will take little bit time. We should wait. That waiting time we are adding here. For that purpose we are taking 10 or 20 frames you can take, and you can sum up our average. Okay, so average alert will be given to you. Even though 1 or 2 frames are predicting wrong, it should not be pop up like that. Okay, if someone is not wearing a mask, if one frame says okay he is wearing a mask, it should not alert. Okay, because these models, any model you build in deep learning, they will be a little bit loss. Okay, we should even take care of that loss. Okay, for that we take average of frames, and everything will be happening in real time. And when you go here, mask code, this is separately tested on the mask detection. Okay, for example, here you see we tested it on single image, small image, whether mask is detected or not for single frames before implementing it in real world. So whatever the stuffs we do, those things will be there here. Okay, training weights. Okay, and also if detection is done, those detection details will be here. So here you see it was a mask detected part, mask 86% positive that this person is wearing mask. That's why on the screen we were able to see that mask is detected. So no helmet, no weapon. Okay, there are no more number of people, so it was very clear. So this was for mask detection. In the same way we do for helmet detection, so we can check that also. If that is available, then only it will detect. Okay, no helmet. Okay, no helmet, there is no helmet, so it says there is no helmet at all. And the same thing happens with weapon. If there is a weapon, it will say there is a weapon, otherwise it will say no weapon at all. So those things, those results only we are displaying onto the front end. So real time this is going to monitor the ATM completely, and it will pop up an alert even though one thing fails. Even he is wearing only helmet, it will be alerted. If he is wearing a helmet, wearing a mask, and he is having a weapon, that also will be detected and mentioned as an alert, so that it will safeguard the ATM even in more complex conditions. Okay, as a human you may make mistake, but these things will be 24 into 7 available, and they will be monitoring correctly. Okay, now we can add few more features, where when instead of getting alerted in that location itself, you can send messages to the server, where like those people can act. Okay, if they continuously get few more commands from here saying okay here 3 times alerted for the for the helmet, so then they can take action physically. Okay, so like that these things will be improved, and also we can add few more extra features. Okay, we'll discuss about it when you contact us. Okay, you can contact us and we can discuss more about this project. We can give you details more in depth, okay, than what we are just showing here. Thank you very much.